Okay, so some of the lab questions. So this is one of the labs that we did in class. This is the one where we actually had the different items and we went to see if they dissolved in water, and then we attached them to see if they conducted electricity. Table salt was a yes, and then it did conduct electricity and it was considered an ionic bond. Sugar was yes. It dissolved, but it did not conduct electricity, and it was a covalent bond. So covalent bonds, remember, covalent bonds are they're sharing. So when it actually dissolves, it's not dissolving into its broken structures. It's actually, okay, I need you to go over there, okay? It's dissolving into sugar molecules. And so because of that, it dissolves, but it doesn't allow the electrical current to go through. Of course, the copper wire, it did not dissolve in water, but it did conduct electricity. And so it's a metallic bond. The crayon shavings, they did not dissolve. They did not conduct electricity, but they are covalent bonds. Because again, they are sharing electrons. And then the baking soda, it did dissolve in water and it did conduct electricity. Therefore, it is considered a likely ionic bond. Any questions with that part? Okay, so we'll go to the next. So these are the questions for that. So some of the questions that we had were which substances are ionic and covalent and metallic? And we answered that in the previous slide over here on the right. So the second question, how does conductivity help identify a bond? So the ionic compounds, they conducted electricity when they dissolved because of the free-moving ions. So when they dissolved, they actually broke apart and became individual ions. So it allowed for electrical conductivity. The metallic substances conduct electricity due to the electrons being shared in there. And then the covalent compounds, they do not conduct electricity because they lack the charged particles because they're sharing them still. Why do some substances dissolve but not conduct electricity? The covalent compounds like sugar dissolve but don't break into ions, so they don't conduct electricity. So that goes back to they lack charged particles. And then what does the behavior of the crayon shavings suggest about covalent compounds? The crayon shavings are insoluble and they don't conduct electricity. So they're considered nonpolar covalent compounds. We'll go deeper into that in the next couple chapters about polarity. The covalent compounds can vary in solubility and conductivity depending on the polarity of them. Okay. The second lab that we did, and Miss Nicole was going to go on this, but she is not joined yet, so I'll just go through this. So we did the electrons and y'all built the shells on there. And so again, this is kind of talking about learning valence electrons and then um, uh, uh, finding out that they're trying to join, that they're trying to become like noble gases. They want to fill up their shells to an octet. So they want to they want to fulfill the octet rule. So number two, what happens when an atom has a full outer shell? It becomes stable and non-reactive like the noble gases. Why do metals tend to lose electrons while nonmetals gain or share them? Metals have few valence electrons and lose them easily to become stable. Nonmetals have more valence electrons and tend to gain or share them. How does the ionic bond model differ from the covalent bond? Ionic transfers electrons, and attraction between oppositely charged ions and covalent bonds involve the sharing of the electrons. So, which we learned previously, covalent, they share, ionic are ions. So they either have a positive charge or a negative charge. If they're a positive charge, they are a cation. And if they are negatively charged, they are an anion. So, okay, so here we go. Ions. I know you've heard a lot about these. We're going to keep learning. So ions are elements with a charge. Remember, if the element is positive, it's called a cation. And so if you have a cation, then it's going to be named like the element. It will just be calcium, calcium ion. If it's an anion, the anion is going to end in "ide." Because I know some people were saying, how do we know how to name a compound or how to name, name something. And so this is telling us. So first we have to identify, is it a cation or is it an anion? So is it positively charged or is it negatively charged? So this example for the anion is nitrogen. The nitrogen, if it was in 3 negative, it would be nitride because we're going to add the IDE at the end of it. And so this is kind of going over what we did in class. So these were the monoatomic ions, which again, mono means one. So it's just one ion. So you have your magnesium, so it'd be magnesium ion, your potassium, potassium ion, oxygen, oxygen ion, oxide ion, sorry. Fluoride would be fluoride ion, lithium, lithium ion, and iodide. So remember, cations named after the elements. If multiple charges, then that's when we're going to use the Roman numerals. If it's an anion, you name the element root. So that would mean like the iodide, the lithium, fluoride, and so on. But then you add "ide" at the end. So oxide, potassium, that one doesn't do it. Magnesium doesn't do it. But the other ones do. The oxide, fluoride, iodide. Okay. Any questions? Okay. So binary compounds. Remember, binary means two. So it's going to mean that there's two coming together. So it consists of two elements, and to name them, you write the complete name of the first element, and then the second element should then be named ending IDE. So again, the ide. So NaCl would be sodium chloride. Ki would be potassium iodide. MgCl would be magnesium chloride. And Ca3 and N2 would be calcium nitride. Yeah, okay. So we added the ID at the ending of all of these. Okay, so practice. So this one right here would be, Isaiah, are you there?
Yes, ma'am.
Okay. Do you know what this first one would be?
Ionic compounds. Are you asking?
How would
You're
be,
asking.
so it would be lithium phosphide, right?
I can't hear you. You're glitching up.
Okay. Okay, I'll just go through it then. So this would be lithium phosphide. This one would be aluminum sulfide. This one would be strontium bromide. This one is rubidium oxide. And Ba, I don't have my periodic table. Ba is, I don't remember. Selenide is the second part, and then CSID would be cesium iodide. So let's see. Oh, Ba is barium. Okay. So what you're doing is when you see this, you're going to find your cation, remember? And your cation keeps the element name. And then the anion, you use the beginning of it, and then you add "ide" at the end. And so, and then the subscript. The subscripts end up, we're going to learn about that in a little bit, balancing our formulas, or balancing our total positive and negative charges. So, okay. So naming ionic compounds. So again, it's kind of repeating that. It's telling us that you're always going to look for the cation first, and you're going to figure out, okay, you're going to put the element. And if it's just an element that has one charge, you just put the name of it. If it's one of those that's in a transition metal, then you're going to put the Roman numeral. So you would do like iron 3 or like over here, cobalt 2, because you'll name which one it is. So then you know that it has a charge of 2 or it has a charge of whatever it says. And then on the second part of the name is going to be the anion. And so the anion for binary compounds, you will use IE ending. like we saw a while ago. So like selenite, iodide, oxide, bromide, sulfide, phosphide. If it's in a polyatomic, which remember polyatomic means more than two, then you're going to do the ion name. So like this one, ASO2 is arsenate. So these are kind of tricky. And so what they say is you actually kind of just have to memorize, or you can use a cheat sheet. So I'll show you in a little bit, but I put together, or I found a cheat sheet that you can use, and we'll use that for future balancing and knowing what the name of the polyatomics are. So, okay, let me see this. Okay, so here is our element. And so this I'll also print as well so we can have it. And it kind of tells you already, so you can look at your periodic table and you can know what your charges are. So again, it kind of goes to our groups a little bit. So we know group 1 has a charge of 1, group 2 has the 2 charge. Group 3 is tricky, but at least you know you can guess 3, at least for boron. And then all of these are going to be either a 4 plus or 4 minus. And then just like I said, these are going to be anions. So they're going to be 3 negative, 2 negative, or 1 negative. And then these, of course, are noble gases. So they have no charge at all. And so when we're trying to balance out, everything is trying to get to the noble gas. Noble gas is like the popular group, and that's everyone wants to be that. So everything when we're writing our compounds, we want to get to 0. So this is something that, again, I will print out for y'all so y'all can have. It's going to be something good to turn back to as a reference. So, okay, this is another one. I put a couple of these in here, and just if y'all can give me feedback of which one you like best, because some of these flow charts are a little bit, just a little bit different. But I mean, they're all useful, but some of them are a little more in depth than others. So again, naming your compounds. So it's all going to be step by step. So you just find out, okay, is it a metal or is it a non-metal? And if it is a metal, does it form 1 ion or more? And then you're just going to follow it down. And so if it's from group 1, then you know it's a 1 minus. If it's a any of these, then you're going to end up using the name of the element, or you're going to use ammonium for NH4, which is a polyatomic known that we're going to try to memorize. If it's got more, then you're going to have the metals and B groups, and you're going to use the name of the element and the Roman numerals. So that means you'll put, again, remember the Roman numerals like number 2, number 3, number 4, however, to give us what the charge is. If it's a non-metal, you follow it down this one. And you're going to find out, is it just 1 atom? If it is, then it's what we did first off, which is the monoatomic, which is chloride or sulfide. And you just use the first syllable and you add I at the end. If it's a group of ions like the polyatomic, then you're going to use the name of that polyatomic ion with either 8 or ite. Here's another one. So here's the polyatomic ion. So this is something I will print with this to definitely kind of give you a reference that you can kind of go to and see, like, okay, if I see this, this is perbromate. If I see this, it's bromate, and so on, and go through there. If you're good at memorizing, feel free to memorize these, but you don't need to. Okay, here is another flow chart. So this flow chart is just kind of going through again. This one is it's breaking it down into covalent, ionic, and polyatomic. This one it's teaching you with the covalent bonds, you're going to use the prefixes that we went through, like the mono, the di, the tri, the hex, the octa, all of those. So the only thing is you really don't need to use mono. It's used for the first element because we kind of know, like, if you're just saying the name, there's just one. And then element on the left of the periodic table is named first. And if hydrogen is present, hydrogen is named first. Halogens and oxygen, the halogen is named first. And then this one, oh, I like this one. The second element ends in "ide," so it's telling you a little more in depth. And if it's an ionic compound, you balance the charges, which we're going to do in a little bit. And then if it's a transition metal, you just go all the way down and you name the cation first and anion second, which then remember you just put "ide" at the end. And if it's not, you come back here, it's a transition metal, then you give it the Roman numeral. So you're going to give like iron 2 or iron 4 or whichever, iron 3. And then you'll come down again and you'll give it the name and "ide." And then our wonderful polyatomic ions. You're going to balance the charges again, and then you're going to figure out, is it a transition, or is it non-transition? And again, transition, you use the Roman numerals, and then you go on and you do your cation. And then cation is named first before the anion. And then with your anion, you name it according to the polyatomic rule, which is hypoperite or 8, which I will have to go more in depth with y'all about that one. Or acid, it's an acid, it's OUS or it. And so that we haven't covered yet. So I think that's covered in the next chapter with acids. So, okay. So now crisscross roll. So this again, to write a formula, which what we're talking about over here, balancing your charges, is using the crisscross rule. So you write your two ions separately, showing their charges, the charges on the periodic table, and then you swap the two numbers and drop the sign. So like with this, your calcium and your nitrogen, nitride. Your calcium is a 2+ and your nitrate is a 3-. And so you just crisscross them in order, and so you're just dropping the 3 and you're dropping the 2 to balance them out. So it's Ca3 and 2. Lithium, same thing. We don't have to write a 1 because we know that if it has a plus, it's got a 1. And then a 2. And so again, you just crisscross it. So it's lithium 2 oxide. So let me see. Here's another one. Aluminum +3 and O oxygen is a 2-. So to crisscross them, we end up getting aluminum 2, oxygen 3. And so that's how we end up getting aluminum oxide. And then lead. So this would be one that's in the transition. And so it's telling us lead 2. So that means it's got a charge of 2. So you're going to put your 2 here. And then phosphate. Again, this is one of your ones that, here, let me see, phosphate. Here. It's over here. It's one of our polyatomic ions. And so we would look over here, what is PO4? 3-. Oh, it's phosphate. So that's how we would know what to put there. And so you don't worry about the PO4, the subscript of 4. You're just worrying about the charge. Okay, so the 4 stays there. All you do is you drop the 3 down here and you drop the 2 down here. But that's why you get the parentheses, because it's affecting that whole the whole compound right there, polyatomic compound. The 2 affects all of it. You don't multiply it at this point. You're just showing that that charge for that compound is the subscript is 2. Oh, and so it's going to be PB3 parentheses PO4 parentheses 2. So lead phosphate. Okay, is this the one that I gave y'all? Does anybody have it in front of them? It is?
Yes, I'm pretty sure.
Okay.
I can double check.
So if you want, we can work the first line. Have y'all worked it yet? Either one of y'all?
No, ma'am.
Okay. So this one, I wish, can I write? Let me see if I can find a pen to write. Yes, I can annotate. Okay. So to write it here, this one, it's Na+ and Cl-. And so this one's already giving us the charges. So then this would end up being yes, sir.
You can also, I think you can type.
Can I type it? Okay.
If you go to annotate, one sec. Yeah, there's a T and it's text. You just click on it and it would
Oh,
be,
okay, thank you.
yeah.
Okay, so then for NaCl, we see that Na has a charge of 1, Cl has a charge of 1, so it's just gonna end up being NaCl. That'll be what that one is. And so then for this right here, CO3 2 negative and Na plus, what would that one be? Anybody? Or I can walk it. Na negative 2. Or actually, it use a negative, so you're -2, and then it would be parentheses, CO3. And that's it. And that would balance that out. Kind of hard to not. So then this one, OH has a charge of -1, and sodium has a charge of +1. So they're going to equal out. So that would equal NaOH. That would be, and then SO4 -2 and Na +2. So you're going to crisscross. We're not crisscrossing the 4, that script 4, we're ignoring it at this point because we just know that that's going to be part of this polyatomic compound. So it's going to end up being Na2 and then SO. And then for this next one, we see that this has a charge of 3. And again, sodium has a charge of 1. So we're going to transfer that. So it's going to be Na3. And then it's going to be PO. Is it making sense? And then this last one, NO3, which is nitric oxide, has a charge of -1, and sodium has a charge of +1. So we'll do Na, and they cancel out because it's 1, 1, so that's 0. And okay. So does anybody want to try NH4 and Cl?
I would like to try.
Okay.
So would it be okay if so is the ones on the left the first element? Like would be
Right.
first. So would you put the NH4 in parentheses and then Cl or no?
No, yes, you can. You can, or you can leave it open like that. You don't necessarily because you're not putting a charge on it because they cancel out. So I guess I did that, didn't I? Yeah. But so you could or you don't have to. Are you able to write on here or I have to write?
Hold
Everyone
on.
can write. There's a pencil in the left corner. Banana.
Yeah. Oh shoot. How do I have to? No.
It's okay. You can tell me and I'll do it. Okay, so you're saying it's gonna be NH4 and then
Yeah.
what?
Cl.
And then Cl. Okay. So do this. So we know that what we're doing. Okay. And then do you want to try the second line? Second one? If you tell me what.
Sure. So it'd be NH. Wait, no. NH4. NH. Wait, would it be NH2 with 4? How would you do that? Wait, no. NH4. Yeah, 2, and then CO3.
Yep, NH4, CO3. But we would need to put this in parentheses here. We could just leave that open. It looks weird to be able to. Hello, Nicole. Welcome.
I made it.
I know. Yay.
Oh, did you get my text messages?
Yes, ma'am.
Okay.
So yes, there would be NH4 and then we're dropping the 2 and then the CO3 doesn't need anything because it just had a 1. Okay, you want to try this
Okay.
one? The OH 1 minus and NH4 1 plus.
Yes, ma'am. Should be NH4 in parentheses with OH.
And then you want to keep going.
Sure. NH4 in parentheses with a 2 and then SO4.
You're doing good. So you got the hang of it then, right?
Yes, ma'am.
Okay, let's just finish this one out, then we move to.
Okay.
So what do you think here?
NH4 in parentheses with NH4 in parentheses with 3 and then PO4.
And then last one.
NH4 in parentheses and then NO3.
Okay. So there you got part of your homework done. If y'all haven't done it. Okay. Isaiah, do you want to try?
Try potassium.
Yes, this one right here.
Okay. So if you swap, would it be K negative? No, K positive, C negative, Cl negative.
Yeah, so they cancel out, so we don't have to write them. We can just do.
Oh,
KC.
okay.
So we can just do
So now would it'd be K1 CO and then in parentheses CO3.
So remember, so you have CO3 with a 2 negative and you have a potassium with a 1 positive.
Yes, ma'am. So it'd be -1 CO3, and then it'd cross. So wouldn't you have positive K?
So you would have K, you would have 2 because you're getting your 2 from here. So it'd be K2 and then you would have CO3
Wait, what?
because you're crisscrossing. The CO3 is a polyatomic compound, so you're just doing the 2 right here, remember? And then you're just
Yeah,
doing the
that's what I was
1.
doing, Mom.
Okay, so you're
If
dropping
K,
2.
Mom, if KCl cancels out, then why doesn't the positive K cancel out the -2 on the
It
CO3?
doesn't because it's only 1. The reason it cancel out is because I just have the 1 minus and that has a 2 plus, I mean, as a 1 plus. So for this one, you have a 1 plus, and over here you have a 2 minus. So in order to balance it and cancel it, you have to bring the 2 here down into the potassium. So it would be K2 CO3, which it would have, we don't have to write it, but the 1 minus would go up there. And those balance out, those would cancel out to 0. They would 0.
Okay.
So you want to try this one? So this one you have a 1 minus and you have a 1 plus.
They cancel out, it's just KOH.
Yes, perfect. Your next one.
K2 SO4.
Perfect, yes. And then your next one.
K3 PO4.
Yes. Okay. And then your last one.
KNO3.
Okay. Okay. Let me see if there's any here that might, is there any that y'all want to try that you think might be a little bit? Page 2. I think this is kind of straightforward. I think we got the hang of it. So if you want to screenshot that, you got your first 3 rows ready for your homework. And just remember, then this actually, I like this setup that we have it like this because you know that you have all your anions here, you have all your cations, sorry, your cations here, your anions here, and you're just so you know what occurs, and then you can look at the charges and go right across. Good purpose. So, do you want to do any more? We can go on. So the next thing we have. What do you get? Okay, moles. Okay, before we do moles, though, Nicole, is there anything else? Did you want to add anything? I kind of went through some of the slides. We went over the labs.
Okay.
But is there anything you wanted to add?
I don't think so. I went through them too before my computer started being funny. Today we started going over the mole a little bit with the other group, but I told them just to watch this video after you explain it. But we did a lot of practice with naming substances and stuff. I think there was a question, but I forgot. Let me find where I wrote down what they asked. Oh, they were just asking with you if there was a quiz this week. That's it. Never mind. Nope, we're good.
Yeah, no quiz since we're doing
Those
I
worksheets.
figured we change it up a little bit.
Okay.
So, okay, so oh, my writing, I don't know how to get that off there. Okay, so moles. We use the moles to convert between mass, volume, and the number of particles in a substance. So we make the conversion from a mole particles and then particles to moles. So it kind of just one goes to another and it can go back and forth. Any combination of the above categories is it. So a mole is the unit of a measure of the chemical. So a mole is Avogadro's number. So this is another number that we get to memorize, the 6.02 times 10 to the 23rd particles. Because we haven't memorized this one yet, right? I don't believe.
No, not yet.
Yeah, so this would be something to memorize is Avogadro's number. 1 mole equals Avogadro's number. So that might be something. You start taking notes of what to write on a cheat sheet. And we might end up having like 10 cheat sheets. Okay, so let me go back over here. So the mole relationship to convert between the number of particles and the mass of the substance. So again, this is going to be doing some math. So the mole, the actual equation is going to be a mole equals the mass in grams. So you're going to go to your periodic table and you're going to find the mass of the element, and then you're going to use Avogadro's number. And it's going to be grams per mole. And so that's how you'll end up. So to calculate the mass of 1 mole of carbon, what is the mass of carbon? Does anybody have their periodic table in front of them? Here. A carbon is 12. So then what they're doing here is they're doing 1 mole times 12 grams per mole, which is what carbon weighs, and that equals its mass. So you can then move this around. So you can do moles times the or yeah, this is going to be our formula. We're doing this so that you know that each one of them, this time this equals that, this time this equals. This will be our main formula. I think. Oh, and then here is the mole to review. Okay, calculate the number of moles and 60.4 liters of oxygen. So oxygen. What is the mass? Anybody can tell? Oxygen is 16. Okay, so if you have 6.4 liters, and our formula over here is moles of mass times Ricardo's number. So you have moles equal mass. So one mole of oxygen. How do you didn't review this one? Did y'all work any problems out before?
No, we had already been there for 2 hours, so we wrapped it up by the time we got to the mall. So I just read that chapter quickly, but I think they were so tired at that point, like nothing registered really.
Giving it figures. So where are they getting this 22.4 liters? That's what I'm stuck at. Does anybody see that?
Let me see. Calculate the number of moles in 60.4 liters of oxygen. When I was reading the chapter in the book, like it didn't explain where to get the amounts from. It talked more about like mass, but it still didn't explain, unless I missed it, like where those numbers were coming from.
So when you look over here to calculate the mass of the mole of carbon, so you're going to do the mass equals moles times.
Because I thought it was like the mass on the periodic table, but then that didn't match the number that was given
Yeah,
in the
that's-
examples in the books. And I was like, it threw me. And so I just read it to them. And then I think because I was confused with what the book said, I just moved
I'm
moved
gonna
on.
need to figure that out because yeah, it's not equal. That's what I would think. So right here would be the 16, but it's not. It's like oxygen is 16.
Yeah,
It's
because it
not.
talks about carbon with the protons and the neutrons in the center being 6 and 6, getting the 12, but then it
Mhm.
doesn't like the rest of it didn't really make any sense.
Okay, so we'll go over that and we'll just have to update that. And I guess what we can do is we can maybe talk about it a little bit at the beginning on Monday.
Okay.
Yes. I thought I had a hand on it and I am not. Not able to. So we'll come back to that on Monday. Is there anything that y'all wanted to go over that we didn't cover or anything that you have questions about other than molds? Nothing. Okay, that's fine. Okay. I guess that's all I had for tonight. And Nicole, you said pretty much that was everything you had to.
Yeah. We just went over like how to name everything. We started with the monatomics and then we went to the binary and then the ternary. And we went through and I made them do practice ones like changing it to ides or whatever it needed to be. So I had them do a lot of practice. And then the crisscross, because Vera was there and she missed Monday. So I kind of had to go over everything you went over. So I kind of redid the whole lesson.
Yeah, that's good. So that's actually part of the, I believe the other homework is naming the compounds, correct? Actually naming the names. One of them was the cross method, and I think the other sheet was naming the compounds.
Okay.
So okay, well we'll go from there.
Yeah, I'll look more into the mole too. I'll see what I can find out because I should have did that sooner.
I know I should have done more. I was putting this together really quick. So but yeah. Okay, guys, thank you so much. Have a good night and a good weekend, and we will see y'all on Monday for our lab. So
Yes.
Okay, I have a question real quick.
yes, sir.
Mhm.
Yes, sir.
So we just got a new phone, and this isn't really related to it, but we just got a new phone, and I am not in the chemistry group. Me, do you think you can try to add me to that?
Yes. How do we add? Do you know how to add? Nicole?
I think you need